Our next talk is going to be about using EasyBuild for Kubernetes-based data science platforms. Over to Graham.
Thanks a lot, Simon. Hi, everyone. Greetings from Quebec City in Canada. And thanks for having me. After so many newbie questions that I asked on the Slack channel, it's about time that I explain a little bit more what I am doing with EasyBuild. So today we're going to see briefly what it is all about, what I am doing at Red Hat, the problem that we may face at some point with the way we are working, the solution that will obviously involve EasyBuild, demos on what exactly it looks like, and then there are some points that maybe I would like to discuss with the community. So without further ado, some introduction and context, because it's important to understand what I'm trying to do before going into the technical details. So who I am, I'm the former head of IT architecture at Laval University in Quebec, where I had the chance to meet with the wonderful guys and girls from Calcul Quebec and Compute Canada, from whom I learned a lot about how to work with this kind of shared environments. That's where I learned about EasyBuild and how it's managed in the HPC world, principally. And now I joined Red Hat in 2019. I am a data engineering architect within the OpenShift data science team. Okay, so my role at Red Hat, it's a global role to help our customers build data science platform on OpenShift, which is our Kubernetes distribution. Okay, so can be pure AI/ML platforms, model training and serving and the rest, or data engineering, data processing in general, both on-prem or in the cloud. So I'm trying to help those different organizations figure out how they can build those kind of platforms. So at Red Hat, we have this strategy on how we approach this problem, and it comes down to that for our users, which is about what exactly a data scientist cares about, which is mostly only their data science stuff, not dealing with infrastructure, not dealing with processing and the rest, which is maybe a set of users that is different from academics users in the HPC world. Here they want to focus only on, let's say, training a model that will be able to do some predictive maintenance in a factory, or to do some image recognition in a healthcare setup. And they want only to focus on that and look at this platform from a totally agnostic point of view on where it runs, how it runs, which package it runs, and which application. They only want to do their work with the tooling that they're used to work with. So in order to do that, we have this community project, which is called Open Data Hub, that allows you to install many different data science tools, common data science tools, on top of OpenShift. For those who are not used to work with that, OpenShift is fully 100% Kubernetes distribution by Red Hat, but it's I would qualify this as an enterprise-grade distribution, meaning it comes with tons of bells and whistles that you would put on top of Kubernetes to have it running in enterprise environments. It revolves mainly around security, data segregation, and all those kind of things that you have normally to put on top of vanilla Kubernetes to achieve something that is stable and secured enough for an enterprise environment. So we have OpenShift. We have also, of course, all the different things from our portfolio, like, I would say Debezium for change data capture in databases. That comes from the middleware thing. We have OpenShift Data Foundation, which is based on Ceph. That is the storage layer that you can fully have into OpenShift. So on top of this infrastructure, we have Open Data Hub, which is an operator that allows you to install all those things easily. Again, for those who are not familiar with this, an operator within OpenShift is, of course, an application that takes care of deploying and managing different tools. So let's say we have Kafka, we have an operator called StreamZ, it's the upstream version, downstream being AMQ streams, Red Hat AMQ streams. So here with the Kafka operator, what you can do is only with a small YAML file, a few specification configuration, you can have the operator deploy and take care of Kafka for you. You want to create a new topic, again, 2 lines of YAML that you just apply to your Kubernetes cluster, to your OpenShift cluster, and it will take care of you of creating the topic inside Kafka and the rest. So it's basically all the intelligence, all the knowledge that operators, that human operators would have to install those things on top of OpenShift that is packaged inside an application container, an operator that takes care of that. And Open Data Hub is that. It's simply an operator that will take care for you of deploying Jupyter, Kubeflow, Spark, and Kafka Selden, tons of different tools so that they are ready to use for your data scientists. Okay, again, that's an open source, fully community project that you can install and use for yourself. And since a few months ago, we also have Red Hat OpenShift Data Science, which is based on Open Data Hub. It's a subset of the tools that you have in Open Data Hub, but as a managed cloud service. So here it's another notch in terms of services, because as a client, as a customer, you don't even care about the OpenShift management or the OpenShift Data Science management. It's just an add-on that you put inside your subscriptions to OpenShift Dedicated, which is the managed version of OpenShift in the cloud. And then you can just consume the service. So notebooks as a service, or model serving, and all those kind of things from ourselves or from partners. So that's the general context in which we are placing ourselves. Now, there comes the problem. And to illustrate this, I've taken this example of the OnDemand Notebook. Okay, so let's say you want to create this as a service Jupyter Notebook thing for all your users. The problem that you are trying to solve with that is, and it's faced, to be honest, by many organizations. You know, you have people installing Jupyter libraries and applications directly on their computers, and then they find themselves just unable to share code, to share data and whatever, because they don't use exactly the same version of this or that. They don't do this in the same way. So the container approach with an on-demand thing is a great way to make sure that everyone's using the same version, which is really, really important for reproducibility and security, especially in an enterprise environment where you are running things into production. Of course, it has to be the same thing every time. So you start by working with container image. So you put your Python-based image, a few libraries and applications that you are interested to work with, and Jupyter with some predefined extensions. Perfect. You have this, and you can provide Jupyter as a service running on OpenShift. So meaning every time someone requests a Jupyter instance, it will spawn a pod, it will spawn a container to which they have access based on this golden image. But then users will want more, which is, okay, that's interesting and everything, but you know, with the base image, you are providing this version of TensorFlow, and I want to use this one, the latest one, or I want to use also TensorFlow, but also maybe PyTorch to do some comparison and this kind of thing. So you are quickly faced with the problem that you have to handle those multiple versions. Okay, TensorFlow 2.5, TensorFlow 2.6. So one solution would be to create different images that people can work with, can select from the start. Okay, let's launch me a new environment with TensorFlow, this version. Perfect. That's one solution. But or the other solution for different packages will also be to have multiple images. Okay, you have one image for TensorFlow, one image for PyTorch, and you can see that it begins to get difficult to handle because there is this sprawl of images that can happen over time, and this begins to get problematic. So you say, okay, let's put everything inside one single image so that you can provide many different libraries. But then you have overweight images, a few gigabytes per image, which is totally not cool to work with, to deploy and sync and the rest. So this is what I call the overweight images. Or you can decide, okay, we don't provide anything, just a base notebook, and we let users do their pip installs, conda installs for what they want. This is something quite standard that you will find, say, for notebooks as a service. You go to Google Colab, it comes with a certain set of libraries, and all the rest you have to install yourself, which works, but then you put all the hassle on the shoulders of the users, which have every time they launch a new notebook, they launch a new environment, they have to redo their pip installs. Plus, you don't have much control on what they install. So it defeats the purpose, which was initially to have those single common images and libraries that people will use. So this is a management nightmare, or your user's nightmare if you decide to do nothing. Okay. Now we may have a solution, and I'm pretty sure here this community knows where I'm going with that. It's the use of EasyBuild. Because I knew EasyBuild from my previous life, I thought it was maybe a good idea to try to apply those principles of loadable modules inside these specific type of environments. So what I'm doing is with EasyBuild, I am compiling modules that I am storing in a special volume inside OpenShift. Okay, that's a volume that is of a special type, a ROX volume, read-only many, meaning that this is a volume that I will be able to mount in as many pods as I want inside my environment. So it is based on CFFS underneath, which is deployed inside the OpenShift, or could also be deployed outside, but that's another discussion. So this volume, what I am doing, every time a new user is spawning a notebook image, I would just mount it at some specific point inside inside the notebook container, meaning I have only to manage one base image, and then I let people pick and choose what library they want to use at the moment they want to use it. Okay, meaning if I want to start working with TensorFlow and then with PyTorch, I don't have to shut down my notebook and choose the new image that has PyTorch built in or do the pip installs and everything. I can fully dynamically load the modules as I need them, exactly like you are doing on your HPC installations. And thanks to a miraculous Jupyter extension that was created by my friends at Compute Canada, I am able to do this in a very easy way for the users. And this is what I'm going to show you live right now. So this is my Open Data Hub environment. So you can see I've deployed some of the tools that you can deploy with the operator. So that's exactly the view that a user would see at the start. Okay, so they would just log in and then they are able to launch Jupyter. So here you can see they have the choice between different images, a standard data science image, a notebook image with SciPy, there is one with TensorFlow, and that's where it gets a little bit difficult to manage when over time you have people wanting this or this new image or updated image and whatever. Here in my case, I have added this image, which I called standard data science modular because it uses module. I can choose the size of my container image, and I will start the server. For those who are not familiar, what it does underneath, and we're going to filter, oops, I'm going to filter this. You see that it is spawning, it has spawned a new Jupyter image, a new container notebook image that is tied to my name. And what it has done also underneath, it has reconnected my own persistent volume where I'm storing my data to this pod. So it's a totally ephemeral environment where it's only at runtime that the volumes are connected and the resources are consumed. Okay, let's go back there. It's finished starting, so Jupyter has to now figure out that it's ready. It should take only a few seconds, I hope. Of course, that's the demo gob or demo devil playing against us. Let's try this. What is happening? Why is it terminating? Oh gosh. Okay, let's do that again. Sorry about that, don't know what happened. It got stuck somewhere in the pod spotting. Meanwhile, I will just check at the chat if there are some questions. No, not yet. And okay, a bad gateway. What? But it is running. Okay. Okay, here we go, finally. Sorry, don't know what happened. It was working perfectly just before the talk, so. Okay, I am in my environment, and as a data scientist, let's say I want to work with this notebook, which is a very simple demo of something that will try to recognize the breed of a dog. And here I have this example of my dog, Peter the Leonberg. And let's try to run this. Okay, we'll try to run. It will first try to import. Oh no, gosh, I have not the Torch Vision modules. What can I do? I have here my extension. So that's the plugin, the extension to Jupyter I was talking about. And here as a user, I can see that I have many featured modules that are available. I could also filter on that and see, okay, with Torch, oh yeah, I have Torch Vision at this version. Let's load this. Just wait a few seconds. So you can see, of course, it's way quicker than doing the pip installs. And then I can come back. Of course, I have to restart my kernel to take those changes into account. And then because now Torch Vision has been loaded, I can go there directly and it will run everything. And it has indeed recognized 98% chance that this is Leonberg. Perfect, it's working. So you see, again, from a user perspective, it's really easy to do the things. And because this is extensions that you load directly, you can, of course, go way further than only loading Python packages. But let's say I want to load an R kernel because you have some users who wants to work with R. So the R kernel has been loaded and now it's appearing here. And then I can launch R scripts, such as one that I have R. I have here my R kernel that I can run easily because now I can have both R and Python kernel, and could be any type of kernel that you want to use. So here it will do this calculation, but We can go even further, which is interesting because we have tons of users who are requesting to work with RStudio. So here, it can also be our studio that I am loading, and I can have it here. And now, because this also includes Jupyter Server Proxy, I can have a full-blown RStudio running inside my environment for the users. Okay, so as you can see, it's a pretty neat way to solve the problems that I have described before of image proliferation that you have to manage and everything. With this, you can provide to your users inside this on-demand environment a set of curated modules and packages that they can use. Of course, there's always, it's part of the extension, you can save a specific set of loaded modules as a collection that you can then restore, that comes from the module, or you can generate the Python code that will load directly the requested modules for a specific notebook, for example. So that means you can easily integrate this code inside another image that will also mount the shared library and have it running in your container, so meaning totally outside of Jupyter. Okay, that's all for the demo itself. And now let's see what's next. I have 2 slides, and then we can go to Q&As. That's an interesting thing that I've noticed when trying to see, I was trying to measure if the fact that using a shared library on a shared drive, even its performance with FFS, if there was no drawbacks compared to having pip installs or directly the packages installed inside a container image. So while trying to do those benchmarks, I find something interesting. For example, with TensorFlow 2.6.0 for an image recognition training, okay, that takes somewhat 30 minutes. I have an improvement of almost 18% speed in training versus using a pip installed TensorFlow version. Exact same version of the packages, exact same version of Python was run on exactly the same container multiple times to minimize errors. So it does not surprise me, and it doesn't surprise many people who are used to work with. It's also concordant with optimized versions that you can find of those tools. For example, we are working with Intel as a partner on their OpenVINO Mulder server or OpenVINO libraries, which has its own versions of TensorFlow or other packages compiled and tweaked by them, and they achieve about the same gain in performance, about 20% faster training time. So again, it doesn't surprise me because all the great work that you guys are doing with those easy configs and easy blocks and the rest with tweaking and carefully crafting the packages for optimization, it totally shines when you are doing this compared to the pip installs, to the pip compiled packages, which are maybe more all-purpose thing, but here it's much better. Of course, it will require further tests and benchmarking, but for us it's really interesting because many of our customers, they are running those kind of things in production with thousands of containers that are doing inferencing in huge production systems. If they can have some gain in the inference or in the training time, because the models are constantly retrained, okay, based on new data that are coming into the systems, having tailor-made container for training or inferencing, this 20% almost gain in speed can be really interesting. Can be also crafted for your specific environment. Okay, you know that you have this or this version of Intel processors or other types of processors. You can enable the flags that you want and everything, just to make sure you take the most advantage of your infrastructure. So that's an interesting point. What's next? We are working, to be honest, in really integrating this way of working inside both ODH, Open Data Hub, and Rhodes. As it solves many problems, plus it will allow us to easily provide our studio, our Visual Studio Code, or whatever directly from inside this environment. But we have to figure out what's the best way to handle the module's lifecycle. Of course, we can let the users self-build their modules, using EasyBuild and everything. The documentation is there; it's great. I know from the previous presentation that it may present some challenges. You have to be an avid reader, to be fair, but then everything is there, and maybe too much. So we're not sure that for our target customers, they would want to go deep inside those kind of considerations. So it's not that difficult. So that's one way of doing this. What we are maybe contemplating is setting up some module repos with some synchronization mechanism, with maybe a serve UI. So when you have this images enabled, you can through the UI go say, okay, I want to my shared library, I want to add this pre-built modules. I know, and here Maxime will say, hey, why don't you use CVMFS and then plug it and everything? Yeah, that's another way to do this, but here we have to consider that we have many different customers, or on the open source world, many different on the upstream world, many different organizations who may want to use this, and they maybe don't want to plug themselves onto a fully worldwide shared CVMFS, or set up their own one. So it's that's something we have to figure out what's the best way. The other thing that I'd like to develop is some tools that will be able to directly package the required modules inside the container image. So of course, you can, let's say you have your code that is working, you want to package it as an API for putting this into production. You can, of course, still mount the shared library so that it can use the different modules, but then the containers becomes dependent on this shared library, meaning it won't be that easy to deploy it in many different environments that may or may not have access to this library. So here, maybe something to package. So let's say you work on your code, you know exactly the modules that you need. Maybe I would create some tool that will that would pre-write your Docker file so that it imports directly inside the container image the modules, the full modules, so that you can create these self-sustained images. The thing that I find interesting is that if we gain some traction with this mechanism, both with Open Data Hub and Rhodes and the work that we'll be doing at Red Hat with that, I think that's a great opportunity to expand the community, maybe outside of just the HPC community, which is the main one that is working with this now. So maybe more contributors for packages and easy configs and the rest. I guess, I hope that this will be the case, that this will happen. To finish, I've added a few references to Open Data Hub, Red Hat OpenShift Data Science. The project that is right now on my on repo is called ODH Highlander. Why Highlander? For the older of us, you know, at the end there can only be one. The goal being having only one base notebook image and then loading everything dynamically instead of having those many images to handle. And that's it for the presentation. And I've seen that there are questions. I will stop sharing my screen. And questions in the chat. Okay, I will start from the top.
Maybe I can raise the question myself for the people who want to.
Go ahead.
Yeah, I'll start with mine. So I was first, I guess. So you showed the example of torch vision, where the import was failing, and you select the module, and then it magically works, right? And you're happy. Have you also considered other Python packages? So in some cases, we combine things. EasyBuild also has extensions. That's a bit confusing in this context, since there's also extensions in your platform. But a concrete example is Pandas, for example, which is included in the SciPy bundle module or EasyConfig. So it's not that trivial to find. Is there a way that people could figure that out easily? Like if they want Pandas, that they actually have to load SciPy bundle in the setup, or do they have to know somehow?
Okay, here first, this setup is purely from, has been built from a demo perspective, meaning have only built some packages so that I'm able to show, okay, you want PyTorch, you have PyTorch, you want TensorFlow, you have TensorFlow. Okay, so it's definitely not the set of packages that we would want to put inside Open Data Hub or roads. Okay, there would be many more, and maybe we would have to change the naming scheme and everything, because for users, you know, PyTorch that FOSS 2021A, that's something, what are they talking about? So that's the kind of things that we have to think about for a more opened version of this for, you know, standard users who don't want to deal with that. That said, in this specific environments, you know, the dependencies are already there, meaning Torch Vision comes with PyTorch, that comes with SciPy, that comes, of course, with Pandas and NumPy and the rest. So everything just, it's just the string that you are pulling out, and everything comes with that, which may be a problem, to be honest, because I was looking at, I did a graph dependencies of all those packages. There are tons of them that just come at load time, but that, in my opinion, would not be that necessary, meaning they are used for build and everything, but then at a higher level, I'm not sure that you need to load specific building tools when you are loading PyTorch, but still there are some that come with it. So it's...
We have a concrete example there, because that shouldn't happen. Like EasyBuild will show you that it needs CMake, for example, to install PyTorch. I'm not sure if that's actually the case, but as an example. But when you actually load the PyTorch module that's installed, it will not load CMake at that point, because that was just a build dependency. It doesn't have to be there at runtime.
I will dig this out. I will dig this out. Yeah. I have the graph somewhere. And maybe I was mistaken in that case. Many apologies, but yes, and that's part of what we have to figure out. That's also why you know, I built upon the extension that Felix Antoine had created for building the modules. That's why I added this concept of featured module, so that they don't have that they don't see all the modules that come with the thing when you have to when you want to load them. So
and I guess for things like Pandas, the search box could basically be intelligent, that it doesn't just look at module names, but also what modules provide. So LMod actually knows, by the way we generate the module files that are being consumed by LMod. LMod actually knows that Pandas is provided by SciPy bundle. So maybe with a bit of extra work in that plugin, you could actually expose that information as well. So if people hit in the search box Pandas, they may see SciPy bundle provides Pandas or something, and they can click that. And
you know, for this, when we will work into integrating this, there will be a full rework of this thing with UX people that would tell us, okay, what's the best, what not, for again, standard users who may not be aware of everything that's happening under the cover. So we will see.
Okay, Maxime has a question as well. Let's see if he's in the Zoom call, so we can let him unmute. Yep.
Yes, I was wondering, have you encountered users who want conflicting version of Python packages that are incompatible with the modules you provide? Well, for example, your module provides NumPy X, and for whatever reason the user uses something that requires NumPy Z, and so it's not already there. And how do you plan to address that, or how do you address that?
Well, right now it's not addressed, to be honest, but and that's the limitation for the notebooks with Jupyter, because the way it works, at least with our images of notebook, it comes with a specific version of Python, which is difficult to override because it's, you see, Jupyter is running as Python code inside this specific virtual environment inside the container. So this is fixed, meaning that when we will provide a base notebook image, let's say at Python 3.9.7, which is the case right now, all the modules that will be provided will have to be compatible with 3.9.7. So they will be built against this specific version of Python. Here, the idea is to provide only what will be, or at least to show only what will be compatible with the specific version of the notebook image that you are using. You know, inspired by what you did, you know, with the code that selects CUDA packages if you have CUDA enabled or not. Here, it will be about the same mechanism that I intend to put in place so that it can select and filter out only the packages that are compatible right now with your environment. And if people ask, let's say, oh, can I have the new version of NumPy? Then it goes to the same process that you are doing right now with someone curating and rebuilding the new version of NumPy that would be available for the specific environment. Does that make sense?
Sure.
But what we cannot prevent is people still doing pip installs inside the specific environment, and then everything will crash because then pip is not able to manage those conflicts in dependencies or not. So.
A different question I had is, so you showed the 18% speed up of TensorFlow compared to a pip install. So that's, yeah, I would say because we pay close attention to how TensorFlow is being installed, and we try to optimize it for the CPUs of the build host. I was wondering, does that cause any trouble in this setup? So is the place where EasyBuild was running when installing TensorFlow, is that the same hardware as where the containers will be running? So is it the heterogeneous setup in the backend in terms of hardware, or?
It was different. In fact, I compiled the module on my own PC, and what you have seen is running into AWS, so different hardware, but no changes whatsoever. I guess it's just the flags that are enabled inside the easy configs for TensorFlow that are a little bit better than what that one is done in pip. And you remember there's been this discussion with the bug in TensorFlow at version 2.5 or whatever. So here, and it's totally out of my league discussing exactly how those compiling work, but I'm pretty sure that people will be figuring this out. Exactly which way we are tweaking those modules, the compilation of the modules, so that it makes them compatible with at as many platforms as we want to run on, or provide the recipes for people to build their own modules for their own platforms. So.
Yeah, that's something you'll definitely have to be careful with, because if I mean, for this test setup, it seems to work. But I guess you maybe got lucky that your laptop isn't brand new and has support some instructions that are not supported on your backend that's running all these sessions. Yeah. That's definitely something. I mean, you can imagine it with it's sort of similar to if your laptop will be an ARM laptop, you wouldn't just ship that to an x86 cluster. That just won't work, and it's a different context, sort of. It's different types of instructions, but it boils down to the same problem.
Yeah, so definitely, and that's what we have to be careful with, and we have to address to see, do we build for each and every platform we are running on, because Roads or ODH or whatever it runs, we have this managed service on AWS, on Azure, and soon in GCP. So maybe we will have to build different versions for those different things because they don't use the same hardware, and maybe even build different versions of the modules depending on the version of the hardware that is running underneath, because in AWS they constantly update the hardware. So maybe there will be, or maybe we'll make the choice, maybe as Pip did, to, okay, let's scale this down a little bit and do a mainstream distribution, but still have the ability for people who want to push this a little bit more to the limit. Okay, guys, here's the recipe to build for your own specific infrastructure so that you can have this gain in performance.
You can actually do both. You could build for, like, say, let's say common infrastructure like Skylake nodes, and then have a fallback to a generic build that's sort of like what Pip does. So if it can pick a fast installation, it will. If it can't, it will fall back to something that should definitely work. And yeah, there's different stages in between that.
Yeah. And maybe, as I was saying, filter out the modules. You know, all the modules for different processors are available in the shared library, but then they are filtered out on what people can load depending on what processor it detects it's running on.
I know you're vaguely aware, at least, of the Easy project, but that's exactly sort of what we're doing there. So doing basically runtime detection of the CPUs and then picking a part of the software stack for that. Okay. I don't see any other questions. I had one more. So this is a demo setup. Does that mean in the not so distant future we'll be bombarded with pull requests by Red Hat to add new software versions, or maybe even new software that you hope to include in the setup? Or
usually that doesn't work this way when we are involved within a community. Maybe you will be bombarded by new people in the Slack channel asking for this or that, or some guidance. But it will be much more, I guess, pull requests for, okay, we have built out this new module that we want to include, and it's already there. We built in for our own purpose. Do you want to add it to EasyConfigs? It will be much more this way. But yeah, that in any way, you know, we know for ourselves, as with the many communities that we are running, we can. It's not that we hate, but, you know, people asking for this or that. Okay, you know, it's open source, so just do this, make a PR, and we'll be happy to consider it. So we wouldn't do the same to you and just asking for things. That's definitely not the way it works.
I wasn't suggesting you would just ask for things and then expect us to come up with solutions for that. I mean, you can always ask, and your request is probably going to sit there until somebody picks it up, which is probably going to be unlikely. But also for pull requests, it's actually a concern, I would say. So I don't know if you saw some of the survey and the statistic results we discussed on Monday, but we're currently already getting 2,500 pull requests a year for EasyConfigs, and we have about, let's say, a dozen maintainers. That's already a lot of work. So if Red Hat actively starts using EasyBuild and pushing it to customers, and that results in, let's say, double the amount of PRs, we'll have a big problem. Yeah. So that's maybe something we should also discuss offline, if we can figure out a good way, if there would be lots of incoming contributions, that we can make sure that we can actually follow up on those.
Anyways, and I don't want to you know, promise or do any engagement or anything, but if we decide to do this, so meaning there is an opportunity for us, that it has some interest for our customers and the rest, what I would see happen anyway is us having our own repo of EasyConfigs for many different reasons, and then having engineers working full-time on this. It would be much more, are you interested in this PR? Then would you take this PR? It should be, okay, we've done this, pick it up if you're interested.
Yeah, and for a lot of things, we probably would be interested, but we need to find time as well to integrate all of that. But yeah, that's probably a conversation we should have offline as well.
Mm-hmm. Sure.
Right. There's another question I see by Okay.
Yeah. For that module tree you had, was everything built with the same compiler toolchain, so you don't get conflicting modules? I didn't see all the module names you had there.
Yeah, everything was using the FOSS toolchain 2021A.
Yeah.
Again, it was a demo environment. Just to show the capabilities of the thing. That's also what we will have to figure out ourselves, which tool chain exactly we are using. Do we enable multiple ones or not? Again, it will come from what will make sense for our customers.
Yeah, because if you mix tool chains in the list,
yeah.
People will choose conflicting modules very quickly.
Yeah, but I guess anyway, everything will be based on FOSS, just because as it will start anyway with an upstream project, it has to be fully open source for everything. So it can only be the FOSS toolchain from this perspective.
Yeah, and I would imagine with a bit of extra work also in the search box and the module discovery part, you could have different sets of modules, for example, like compatible sets with different tool chains, or so that there's lots of things you can do there to keep it manageable.
Yeah, again, that's the UX people who will tell us, okay, this is what maybe there would be 3 different search bars and filters and things that you can select from depending on what you want to do.
You have to find a balance, but yeah.
Exactly. Again, remember that our target people or target users are really different from HPC users. Okay, those are mostly data scientists working in organizations, in enterprises. So they know how to run models, train models, and the rest, but not the deep intricacies of what could be done exactly with CPU tuning and all those kind of things. They just use the packages, so it has to stay simple. If we, the purpose of Open Data Hub and OpenShift Data Science is to make this easy for these people to just use the tools. So we don't want to complicate it too much with too many modules or tool chains to choose from. I guess it will stay on the easy side.
And there's probably something we could learn as HPC admins from that as well, because the things you're saying is true for lots of our users as well, where they just really care about running TensorFlow or PyTorch, and whether it's Python 3.8 or 3.9 or optimized for this specific CPU, they couldn't care less. Like the system admins care because they know there's going to be a big impact on performance, but for them, they just want to, please give me my software and let that work, right? So there's probably stuff we could learn from each other there, I think, back and forth. Okay. Maybe a last call for questions before we do a short break and switch over. Or we can wrap up, Simon, and I don't see any other questions.
Thank you for the talk, and we'll get ready for the next one.
Thanks a lot, Guillaume.
Thanks for having me, and thanks again to the whole community, because I've asked some very newbie questions at the beginning in the Slack channel. Everyone